In this lesson, we're going to talk about simplifying expressions, and specifically, we're going to talk about combining like terms, and then later, we'll talk about combining like terms with distribution. But first, let's talk about what an expression is. So this entire thing is an expression, okay? This entire thing is an expression. An expression is a mathematical phrase that has two or more terms. So the next thing we're going to talk about is what is a term? Well, terms are the pieces that are separated by plus or minus signs. So this right here would be a term. And this here would be a term. And this here would be a term. Within the terms, we have some vocabulary words to learn as well. Here we have a variable. A variable is a letter that represents an unknown value. Okay, so we have a variable of x here. You could have variables of y, of a, of b, of c, of, we've got 26 possibilities and then some. So variables, usually you're going to see x and y, occasionally a, b, and c. But really you could have any letter to represent an unknown value. So this value right here is multiplying on this 3 in the front, and that 3 is a number multiplying on a variable, right? So this 3 would be a coefficient. A coefficient is a number that is multiplying on a variable. So a coefficient times a variable make up a term. We have another coefficient right here. The 4 is multiplying on the variable, so that makes the 4 a coefficient. The x is the variable, and the whole thing, 4x, is a term. The last term that we have over here is 2, right? It's just a number. It doesn't have a variable. This is a constant. A constant is just a number without a variable. Okay, it could be positive, it could be negative, doesn't matter, but it is a number without a variable. Okay, the last thing that we're going to talk about is like terms. So we have terms here. I have 3 terms, but only 2 of these are like terms. To be like terms, you must have terms that have the same variable, and on that variable they have the same exponent. For example, here we have just x with no exponent, and we have x with no exponent, so that makes these 3x and 4x like terms. And that's important because today we're going to work on combining like terms. Okay, now just as a heads up, when we combine these like terms, all we do is add the coefficients, add or subtract the coefficients. So I have 3 plus 4, which would make 7, and then I bring down that variable. The variable doesn't change. It's how we use, or how we match the terms, I'm sorry. Okay, so 3x and 4x are like terms. We have variables, we have coefficients, we have constants, we have 3 terms in this expression, and the whole thing is the expression. Okay, so that's a quick vocabulary lesson. Let's do a little practice with naming. So do these next problems with naming. Awesome. Let's move on to some actual examples of combining like terms. So as you can see in this expression, how many terms do we have? We have 1, 2, 3, 4, 5 terms. Awesome. So we need to figure out who are the like terms. So let's start with the terms that have the variable x. How many terms have a variable of x? 3. We have the 5x, we have a positive 2x, and then we have a positive x. What do you think the missing coefficient for this term would be? It's a 1. So you can put a little 1 in there, and that's important. A lot of students think that it's a 0, but that would mean that this term doesn't exist if it's a 0. So we have to put a 1 in there. Okay? What I want you to do is I want you to write out these terms all together. So I have 5x plus 2x plus 1x. Awesome. What do we have left? We have a 1 and we have a negative 3. What was the vocabulary word for this type of term? It's a constant. There's no variable on either of these. Now, even though these constants are different, constants are always like terms. So this positive 1 and this negative 3 are like terms. So I've organized them so that all my like terms are together. Now I'm actually going to combine them. And remember what I said earlier, that when we combine like terms, we add the coefficients. So I'm going to add the 5 plus 2 plus 1, and that makes 8. And then I can bring down the variable. I don't change it. It doesn't become x to the third. We just bring it straight down. And then I'm going to combine my terms back here with the constants, and I do have a subtraction, so I'm just going to do a quick state change, make this 1 plus a negative 3, okay? And so if you think back to our integer operations that we worked on in the last module, this would be 1 positive and 3 negatives. These cancel. I have 2 left over, so this would be a negative 2. So my final answer is 8x minus 2. Not too tough, right? Let's look at another example. So in this example, I have k to the second power. I also have just k. Would these be like terms? Remember, I said that like terms have to have the same variable, which we do, but they also have to have the same exponent on that variable. Do these have the same exponent? No. This first term has an exponent of 2, and the second term doesn't have an exponent at all, which means they're not the same. So these are not like terms. Now looking at this 5k to the second, who would be a like term? Negative 9k to the second. So I'm going to organize those, 5k to the second, and I'm going to say plus a negative 9k to the second. Then I know I have this 7k and this plus k. Again, what's the coefficient for this k? It's a 1, so I can say plus 7k plus 1k, and then we just need to combine what? What do I actually add? I'm going to add the coefficients. So I have 5 plus negative 9, which makes a negative 4, and I'm going to leave the k squared. And then I have the plus 7k and the plus 1k, which makes plus 8k. And that is my final answer. I can't combine anything else because, again, these variables of k don't have the same exponent. So we're done. Let's try another one. In example 3, we have 9x to the third plus 2x minus x to the third minus 5x. How many terms do we have? Remember that terms are separated by plus and minus signs. So I have 1, 2, 3, 4. 4 terms. So this 9x to the third, is 2x a like term with 9x to the third? No. We don't have the same exponent. This is 9x to the third. This is just 2x. So it's not a like term. It is negative x to the third, a like term with 9x to the third. Yes. Again, we have that same exponent. How about negative 5x? Is negative 5x going to be a like term with 9x to the third? No, it doesn't have the same exponent. So I'm just going to organize these by saying 9x to the third plus a negative what? X to the third. What is the coefficient here? It's a 1. Awesome. So this positive 2x doesn't have a like term. Yes, it's the negative 5x. So I can say plus 2x plus a negative 5x. Awesome. Now, what pieces do I actually combine? I'm going to combine just the coefficients for those like terms. So 9 and negative 1 make 8, and then I bring down the x to the third. Positive 2 and negative 5 make a negative 3, and I bring down the x. So that is my final answer. Let's do example 4. So I have here a negative 3r plus 5y plus 5r minus 7y. Who is the like term for negative 3r? Awesome, it's positive 5r. So I can say negative 3r plus 5r. Then, who's the like term for 5y? Negative 7y. So I can say plus 5y minus 7y. Then I'm going to combine what? Just the coefficients. So this is going to become 2r and negative 2y. Done. Now, I do want to point out that these terms you can put in any order that you typically want unless it says standard form. Usually you will see it in standard form, which means that our variables are in alphabetical order with the constants at the end. So if you were to say negative 2y plus 2r, that is technically the same thing. However, to be in standard form, this would be your actual truly simplified answer in standard form. So let's try to write our answers in standard form like this, but know that this is saying the exact same thing. All right, example 5. How many terms do we have? 5 terms. Let's start with the 6g. Who's the like term for 6g? Negative 3g. So we're going to say 6g plus negative 3g. The next term is that positive 6j. Who is the like term? The positive 3j. So plus 6j plus 3j. And what type of term is left over? A constant. We have the constant negative 7. Does it have any like terms? Not in this example. It's the only term that doesn't have a match. So let's start combining our coefficients. 6g plus negative 3g would make what? 3g. 6j plus 3j would make what? 9j. And what about this constant? We're just going to bring it down. There's nothing to add to it. And that can happen with any type of term. You don't always have a like term for every term in your expression. And if that's the case, you just write it down. Now think about this. Is this answer in standard form? Yes, this is in standard form because in alphabetical order we have G and then J and then our constant is at the end. So this is my final answer. Let's try some practice.